Let us see a few more questions on software engineering. The topic is software reliability. First is which of the following is not a phase of bathtub curve of hardware reliability? Which of the following is not a phase? Useful life, burn in, wear out, and time. The answer is D. Time is in the horizontal dimension on which the bathtub curve is built and not the phase. So this is this time comes in the horizontal dimension. Second is how is reliability and failure intensity related to each other? Reliability and failure intensity. So direct relation, inverse relation, and no relation. The answer is B, which is the inverse relation. That means as this failure intensity decreases, the reliability increases, or you can say that reliability will decrease if the failure intensity increases. Next is how many product quality factors are proposed in McGraw quality model. McGraw quality model, how many product quality factors are proposed in McGraw quality model? The answer is B. There are three, and these three actually there are various, but the product quality factors are proposed in three parts. That is, first is where your product revision, then you have product operation, and then product transition. So you have product revision, product operation, and then product transition. Next is which of the following is not a software quality model? So you need to be aware of the various software quality models which are there. So which one of the following is not a software quality model? ISO 9000, McGraw-Hill, ISO 9126. The answer is clearly ISO 9000, because these are the standards or series of standards which is set of document dealing with quality system that can be used for quality assurance purposes, right? These are series of standards which say or talk about how it should be. It doesn't talk about the product. It tells you about the processes and how the process needs to be managed. So ISO 9000 is, if you say that my company is ISO certified, that does not mean that you have a quality product. You say that you are doing everything to have a quality product. What is MTTF? Mean time to failure. What is MTTF? The answer is B, mean time to failure. Next is how is software reliability defined? How is software reliability defined? In terms of time, efficiency, quality, or speed. Software reliability, if I can tell you the definition, is the probability of the software or a product working correctly for under a certain environment for a period of time. So the software reliability defined, I just defined in the last phrase I said in particular duration, that is the time. So software reliability mainly concerned with the time component or duration component. So it can be seen in various models like basic execution time model and logarithmic Poisson execution time model. Now the next is suitability, accuracy, interoperability, or this security. So suitability, accuracy, interoperability, and security are what type of quality attributes of ISO 9126? Is it reliability? Is it efficiency, functionality, or usability? Suitability, accuracy, and interoperability and security. These four are the functionality. So they are quality attribute of ISO 9126. This type, the answer is C, because all the characteristics mentioned in the question are related to the achievement of basic purpose for which the software is being engineered and which is our functionality. Next is time behavior and resource behavior fall under which quality attribute of ISO 9126? Time behavior and resource behavior under which quality attribute of ISO 9126? The answer is efficiency. So these characteristics mentioned in the question are related to the relationship between the level of performance to the software and the amount of resources used and the stated condition which corresponds to the efficiency, time behavior and resource behavior. Next is NHPP. NHPP stands for which of these options? Can you answer this? NHPP. The answer is D, non-homogeneous Poisson process. Non-homogeneous Poisson process. Then the next is the CMM model is a technique to capability maturity model. This is a model or it is a technique to automatically maintain the software reliability, improve the software process, test the software, all of the mentioned. So the answer would be B. This is to improve the software process. So capability maturity model or CMM is a strategy for improving the software process irrespective of the actual life cycle model used. So here capability maturity model, you are not aware or you are not worried, not aware, but you are not worried about the software model or software life cycle model you have employed, but you are interested in improving the software process. Next is the dependability and security aspects of software engineering. First is a characteristic of a software system that can lead to a system error is known as a characteristic of software system that can lead to a system error is known as either human error, mistake, system fault, system error, system failure. The answer is B, system fault. The answer is self-explanatory. Next, an erroneous system state that can lead to system behavior that is unexpected by system users is known as erroneous system state that can lead to system behavior that is unexpected system behavior by systems is called what? Very simple. The answer is the error which has come. Third, an event that occurs at some point in time when the system does not deliver a service as expected by its user is called an event that occurs at some point in time when the system does not deliver a service which is expected by the user, or it is being provided through the user by saying that this is being provided to you. The answer is the D1, system failure. Next is a chemical plant system may detect excessive pressure and open a relief valve to reduce this pressure before an explosion occurs. What kind of dependability and security issue the example states? See, this is some hazard kind of thing only, but we have to find out that if in a chemical plant system we detect excessive pressure and open a relief valve to reduce this pressure before an explosion occurs. This is hazard avoidance or detection or removal. What is this? The answer is D, the hazard detection and removal. The system is designed so the hazards can be this kind of hazard can be detected and it can be mitigated or removed before they result in an accident. Next is an aircraft engine normally includes automatic fire extinguisher. What kind of dependability and security issue the example states? An aircraft engine has automatic fire extinguishers. So the answer is B, damage limitation. Damage limitation, that means the system may include protection features that minimize the damage that may result in case some accident must occur. Next is an assessment of the worst possible damage that could result from a particular hazard is known as the assessment of the worst possible damage from a particular hazard, and the answer is risk or hazard severity. So the answer is the assessment of worst possible damage that could result from a particular hazard is known as the hazard severity. So hazard severity can range from catastrophic, which many people are killed, so life-threatening, to minor, where only minor damage may result. When an individual death is a possibility, a reasonable assessment of hazard severity is very high. Next is which of the following terms is a measure of probability that the system will cause an accident. Which of the following terms is a measure of probability? The answer is A, the risk, which is the most important thing in SDLCs right now. This risk is the probability actually that the system will cause an accident. The risk is assessed by considering the hazard probability, the hazard severity, and the probability that the hazard will lead to an accident. Right? Next, a weakness in a computer-based system that may be exploited to cause loss or harm is known as vulnerability, attack, threat, or exposure. The answer is A, vulnerability. Next, a password checking system that disallows use of password that are proper names or words that are normally included in a dictionary is an example of dash with respect to security system. Asset, attack, control, risk. A password checking system that disallows user password that are proper names or words. And this is, of course, the control protective measure that reduces the system's vulnerability. Next is the safety of a system is a system attribute that reflects the system's ability to operate normally or abnormally without injury to people or damage to the environment. The safety of a system is a system attribute. Is it like that? Yes. It's very true that the safety of a system is a system attribute that reflects the system ability to operate normally or abnormally without injury to people or damage to the environment. Now we come to the third topic of today, dependability and security specification. Dependability and security specification. The first question is, how many stages are there in risk-driven requirement specification? How many stages are there in risk-driven requirement specification? And the answer is B, 4. So what are these 4 risk-driven requirement specification? These include the risk identification, then risk analysis, risk reduction, and risk decomposition. So identification, analysis, reduction, and decomposition. Next, consider a case where the system is unavailable and cannot deliver its services to users. Unavailable and cannot deliver its services. So what type of failure is being described here? Loss of service, incorrect service delivery, or system data corruption? The answer is A, loss of service. So one may separate the list, this into loss of critical services and loss of non-critical services. This loss of service can be divided into loss of critical services and loss of non-critical services, where the consequences of the failure in a non-critical services are less than the consequence of critical service failure. The next is consider a case where the failure of the system causes damage to the system itself or its data. And what type of failure is being described here? System data corruption, is it the answer? Yes, the answer is system or data corruption. Next is PERFORD. PERFORD stands for what? Can you answer this? PERFORD is probability of failure on demand. Probability of failure on demand. Next is which reliability metric sets out the probable number of system failures that are likely to be observed relative to a certain time. What is this reliability metric? Actually, the content which is being said, this statement is reliability only. So we are talking about the reliability metric here. Reliability metric sets out the probable number of system failures that are likely to be observed related to a certain time period is nothing but the ROC-off, that is the rate of occurrence of failure. Rate of occurrence of failure sets out the probable number of system failures that are likely to be observed related to the number of system executions. Next, which of the following is not a functional reliability requirement for a system? Checking requirement, recovery requirement, redundancy requirement, and ambiguous requirement. Answer is clearly the ambiguous requirement. All the options are correct. That is, neither checking nor recovery, also this redundancy, they are not a functional reliability requirement. Next is, to specify a security requirement, one should identify the risks that are to be dealt with. To specify a security requirement, one should identify the risk that are to be dealt with. The answer is false. To specify a security requirement, one should identify the assets that are to be dealt with, not the risk. The aim of preliminary risk analysis and assessment process is to derive security requirements for the system as a whole. Preliminary risk analysis and assessment. The aim is to derive security requirement for the system as a whole. The answer is yes, absolutely correct. In a preliminary risk analysis stage, decisions on the detailed system requirements, the detailed design, the system design, or the implementation technology have not been made. Next, at which stage of risk analysis specification the additional security requirement take account of the technologies used in building the system and system design and implementation decision? At which stage of risk analysis specification? Preliminary risk analysis, life cycle risk analysis, or operational risk analysis? The answer is B, life cycle risk analysis. So the risk assessment takes place during the system development life cycle after design choices have been made. Then, next one. Which reliability requirements are concerned with maintaining copies of the system? Reliability requirement. Maintaining copies of the system. Recovery or redundancy or checking requirements, ambiguous requirement? The answer is clearly the recovery requirement, because these requirements are geared to helping the system recover after a fail has occurred. So this is all for today. This is one more session and there are various sessions left. Thank you so much. Take care.